Hello students, welcome back to my YouTube channel. I am Shlok Kulkarni and today we are going to continue with the next departure questions from Oxford Gen Nav. So far we have done 12 questions and now we are going to do the last three questions, question 13 to question 15. I hope you have understood all the questions that we have done so far and you are comfortable solving them on your own. So let's begin with today's question, question number 13. Aircraft departs a point 04 north, 170 west and flies 600 miles south. Then it goes 600 miles east, then 600 miles north and then 600 miles west. What is its final position? So, we are told to find the final position of aircraft which has flown all these points. So, starting from 4 north, 170 west. So, let's draw a rough diagram. So we have point A, which is 4 north, 170 west. Then it goes 600 miles south to point B. Then it goes east, point C. And then it goes again north. And then it goes to west. What is its final position? So let's start with the first segment or the first route, which is 04 north, 170 west to 600 miles south. So we have So this is 04 north, 170 west. So now as you can see, both these points are at same longitude, right? So the longitude of B will also be 170 west. What will change is that the latitude. Point A is 4 north. Point B latitude will be something else. Now this flight comes down from A to B, okay, and it covers, in so doing, it covers a distance of 600 miles. 600 nautical miles. Okay, now here we can see that A is at 4° north. When it comes down, the latitude value will decrease. Okay, when you fly down across latitudes, your value of latitude decreases. When you fly above towards the North Pole, your latitude value increases in the northern hemisphere. So, what will be the latitude of point B? Definitely less than 04° north. It can be equator or it can enter southern hemisphere also. So let's keep ready an earth for our reference. For latitudes, you will draw the side face of the earth. This is your 0°. Currently, you are at 4° north. Now let's see what will be a D latitude. So great circle formula is great circle distance is equal to D lat into 60. So distance is 600 miles. D lat I do not know, into 60. So D lat will be equal to 600 divided by 60, which is equal to 10°. So that means the difference between two latitudes is 10°. Now looking at this figure, I have a difference of 4 here. What is the total difference? 10°. Out of those 10°, 4° is between 4° north and the equator. So remaining 6° will enter the southern hemisphere and therefore our new latitude will become 6° south. 6° south. So the latitude of B is 06 south. 06 south. Okay, so this is how we have found the first part of the route. Now let's go to second part. I will draw it again here. We have A here, B here, 06 south, 170 west. A is 04 north, 170 west. Now the next part of the question is, it goes 600 nautical mile east from B. Okay, so let's draw that 600 nautical mile east from Bravo. The total distance is how much? 6 600 nautical miles. Now when it goes from Bravo to Charlie, as you can see, both are at same location, same latitude. So latitude of Bravo 6 south will be equal to latitude of Charlie 6 south. So I am writing the same latitude 06 south. What will change is the longitude. If Bravo is at 170 west, when you fly easterly direction, your longitude of Charlie will be a new longitude. It will change. Okay, it will change. So next point is, use your rumline formula. Rumline distance equals to d long in minutes into cos of latitude. D long in minutes into cos of latitude. Okay, Rumline distance is d long in minutes into cos of latitude. So put the values, substitute the values, that will give you 600 nautical miles. 600 nautical miles equals to d long. Since I only know one longitude, I cannot find the difference between two longitudes, into cos of 06. So d long in minutes is equal to 600 divided by cos 6. That will be equivalent to, use a scientific calculator, 603 minutes, or d long in degree if you want, that will be equivalent to 603 minutes divided by 60, 10 degree 3 minutes. 10 degree 3 minutes. Okay, so that is the difference between two longitudes. Now let's draw the earth. When we are talking about longitudes, the figure will be different. North 0, 90 west, 90 east, 180 east, 180 west. Now first point is 170 west. So 170 west will be over here. 170 west will be in the western hemisphere. Now you have flown an easterly direction. You have flown an easterly direction. That means when you look at this diagram, all easterly directions are anti-clockwise in direction. All easterly directions are anti-clockwise in direction. Okay, from top of the earth. So your difference in longitude is 10 degree 3 minutes. So from 170 west, when you fly easterly, your track will be like this, anti-clockwise. Okay, anti-clockwise track will it be. And next, difference of 10 degree 3 minutes. So if you are going left hand direction, anti-clockwise direction, your longitude value will go on decreasing. So 170 west, new longitude will be, new longitude of C will be equal to 170 west, which is the initial longitude, minus 10 degree 3 minutes. So that is equal to 160 degree. So 170 degree minus 10 degree 3 minutes is 159 degree 57 minutes. And the hemisphere will be the same hemisphere. We are in the same hemisphere. So western hemisphere. So the longitude of Charlie is 159 degree 57 minutes west, approximately 160 degree west. Okay, approximately. So this is the second part or the second root of the question. Let's go to next part. I will take a new slide. So the next part is from 600 nautical mile east. Now we make a left turn and fly a heading of north. So let's draw that. So this was a B, C. C was at 06 south, 159 degree, 57 minutes west. Now from here it goes D for a distance of 600 miles, a distance of 600 miles. So what will be the coordinates of point D right now? What will be the coordinates of point delta? Now since both are on the same longitude, the longitude of C will be equal to longitude of D. So let's write the longitude of D as 159 degree. 159 degree 57 minutes west. 159 degree 57 minutes west. Now let's find the latitude. Latitude of C is 6 degrees south. So latitude of delta will be more than 6 degrees south. It can be in the equator or it can be in the northern hemisphere. On the equator or in the northern hemisphere. Since when we are flying a northerly heading, the latitude value will decrease as long as we are in the southern hemisphere. 6 will become 5, 4, 3, 2, 1, 0. At equator, when we continue our northerly heading, and the value of latitude will now start increasing. 1 degree north, 2 degree north, 3 degree north. So remember the hemisphere you are in. Accordingly, the latitude value will increase or decrease. Accordingly, the latitude value will increase or decrease. Okay. For a simplification, then let's draw the latitudes. 0 degree equator, 6 degree south. Now we are going in the northerly direction, so this will be a great circle track. So great circle distance is d lat into 60. Put the value 600 equals to d lat into 60. So d lat equals to 600 by 60 is equal to 10 degree. So our new latitude will be, total difference in latitude is 10 degree. So initially when going from 6 degree to 0 degree, we will cover a difference in latitude of 6 degree. Now what is the difference remaining? Out of total 10 degree, we have traveled 6 degree. So the remaining D lat is 4 degree. So we will travel 4 degree up and we will reach a new latitude of 4 degree north. We will reach a new latitude of 4 degree north. Okay. So latitude of delta is equal to 4 degree north. 4 degree north. So these are the coordinates of delta. Now let's go to the next part of the question. From here, from delta, we go 600 nautical mile west. 600 nautical mile west. Okay. So I will plot that. So this will be a final destination. Now why have I exceeded this latitude or this route of flight beyond A? For the reason is that I have explained that in the previous departure sum video also. When we take our Earth, we have two meridians converging at each other or converging with each other. So this is meridian number 1, this is meridian number 2. Now the difference or the d long between these two longitudes here will be this much. So the distance, so d long is going to be the same. The difference between two longitudes as you go towards the North Pole is going to remain the same. But what will change is that the distance between two longitudes will change. Will change. How? Now look at this. Look at this first arrow. Okay, what happens here? Here we will have a particular distance of, let's say, 10 miles, 10 nautical miles. When we go northerly direction, you can see this distance is lesser than this distance clearly, and that is because of the convergency of meridians. So as the meridians go on converging, the distance between them go on decreasing. So if this is 10 miles, this will be less than that 8. If you go still above, you can see this distance is less than this and still lesser than this. So this distance will be 6. Again, this distance has decreased between two longitudes. D long is the same, but distance between them has decreased. So it has become 4. So on and so forth. At North Pole, the distance between these two poles will become 0. Okay, at North Pole, both meridians will converge and there will be a just converging point. So the distance between them becomes 0. So that's why as you go northerly direction, when you are in the northern hemisphere, convergency of meridians increases, due to which the distance between them go on decreasing. So now we are going to apply this concept over here. Here we are at 6 degrees south. From here we have gone to 4 degree north. Okay. So what happens at 6 degrees south? We have a particular convergency. When we go at equator, the convergency is 0. Okay. At equator the convergency is 0, because just at the equator two meridians are parallel to each other. Beyond that they start converging, northern hemisphere or southern hemisphere. Again, when we go towards 4 degree north, what happens? The meridians will start converging. Okay, so that's why the d long here will be equal to AD long, but the distance may be equal to that or more than that or less than that. So let's check. We will solve this over here. Okay, we will solve it here, and let's check whether E is going to be here, or it is going to be here, or it is going to be before A. Okay, so there can be any three possibilities in this particular sum, because in this sum what we have been given 6 degrees south and this is 4 degree north. So by concept of convergency, the convergency at 6 degrees south will be more than the convergency at 4 degree north, right? 4 degree north, because 6 is more than 4 and convergency is proportional to sine of latitude. So sine of latitude means as angle increases, 4, 5, 6, convergency increases. So compared to sine of 4, sine of 6 will be greater. And therefore, we may have point E, our destination, final destination, before A. We may, in this question particularly, we will not exceed point A, because convergency here at 6 degrees south will be more. And therefore, the distance between Bravo and Charlie will be less than echo. So let's solve this. Rumline distance is equal to d long into cos of lat, 600. Okay, again we have covered a distance of 600 miles from D. is equal to d log in minutes into cos of latitude is 004 degree. So d log equals to 600 divided by cos 4, that is equal to 601 minutes, or 10 degree, or d log will be equal to 10 degrees approximately. Okay, so that is the case. So d log will be 10 degree. So now our initial longitude is, let's draw the earth for that route of light. So for our longitudes, our earth diagram will be like this. So 159 degree 57 minutes west. So western hemisphere is this. We are here. 159 degree 57 minutes west. Next, our D long. Next, they say we are going to fly what direction? 600 nautical mile westerly direction. Okay. So as you can see, that direction will be westerly. This is easterly, north, and south. So westerly directions are always clockwise directions. Westerly directions are clockwise directions. So when you go clockwise or you go right hand side, your longitudinal value will go on increasing 159, 160, 170, 180. After crossing 180 and you enter eastern hemisphere, it will again start decreasing. So now our total D log is 10 degree. Okay, and our initial longitude is 159 degree 57 minutes. Westerly direction longitude increases, so you will add 159 degree 57 minutes plus 10 degree, that will give you longitude at echo. So answer will be 169 degree 57 minutes is your longitude of echo. Okay, so your echo is over here, 169 57 minutes. Okay, so now let's write the coordinates here. 4 degree north, 169 degree 57 minutes, or approximately 170 degree. So what is the longitude of A? Longitude of A is 170 west, and longitude of E is 169 degree 57 minutes west, approximately 170. So that means echo or point E, which is a final destination, is very close to point A within a few minutes of longitude. Okay, so this is the final destination. So let's look at the formula. It is 4 degree north is for sure. Okay, 4 degree north. So let's look at the options which have 4 degree north: A, C, and D. And then the longitude that we are talking about is 169 degree 57 minutes. So 169 degree 57 minutes is option Charlie. Okay, closest accurate option is that. Okay, approximately 170, but for exam, select the option 169 degree 58 minutes or 59 minutes, that what we got. So this is how you solve the sum. Draw the rough diagram, solve each route separately with the help of a figure like this, and then corresponding figure like this for every route. Write the formula correctly, substitute correctly, use a calculator correctly. Same for run line, find the new longitude, then proceed to the next segment of flight. Again, you write the formula, substitute the values. Same goes with the run line, right? And then remember this concept of convergency. Okay, the now point E will have exceeded point A only and only when, let's say, we would have instead of reaching altitude 4 degree north, if we would have reached any latitude more than 6 degree, like 7 degree north, 8 degree north, 9 degree north, okay, so more the latitude, more the convergency. So our goal is to have a convergency more than 6 degree. So only and only then point destination will exceed point A. If you have reached your latitude which is less than 6 degrees south, so that new latitude will have, which is lesser in value, will have lower convergency, and therefore lower convergency means distance will be more than the distance between these two longitudes. So that's why uh, this will exceed, CB distance will exceed in value, but E will be over here, up to here only, okay, because the distance at 4 degree north between two longitudes is going to be more than distance between two longitudes at 6 degrees south, and therefore BC has exceeded compared to point E in this sum. So this much exceeding has happened, okay. But in the opposite case, if latitude of delta would have been more than 6 degree, echo would have been thrown outside of A. So echo would have exceeded. So I hope you will understand this concept. Let's go to next sum. Question 14. Very important. Aircraft is flying around the earth easterly direction at 60 degree latitude at a speed of 240. At what speed would another aircraft have to fly same direction of east along the equator to fly once around the earth in the same time? These are the options. So, very important, let's draw the earth. Let's understand the basics. If this is your earth, we are concerned about two latitudes now, 60 degree north and equator, which is 0 degree north. Okay. Now, definitely due to the compression of the earth, right? Due to the compression of the earth at the poles and the bulging at the equator, our equator, our earth is somewhat like this, oblate spheroid. So the distance that you will cover when you travel 360 degree around the earth along the equator, along the equator will definitely be more than the distance that you will cover when you travel 360 degree direction around the earth at 60 degree north latitude, at 60 degree north latitude, okay, because of the unique shape of the earth. The equator is bulging, okay, so the equator has more area, and 60 degree north, as we go towards north pole or south pole, there is compression of the earth, so the distance that you cover 360 degree at 60 north will be definitely lesser than the distance that you will cover along the equator because of the shape of the earth, purely for that reason. Therefore you will quickly cover 360 degree at 60 degree north latitude because the distance is less, okay, but you will take some more time to cover a 360 degree direction at 0 degree north latitude at equator because the distance is more. Now the question states that if now the question states that you are traveling at 60 degree north at a particular speed of 240 knots, and let's say you cover this total 360 degree direction in 10 hours. The second part of the question says, what should be your speed when you fly along the equator and you are going to make a 360 degree turn in the same amount of time, in the same journey time. So the time that you have taken to travel at 60 degree north is the same time available for you to cover a distance of 360 degree at the equator. So you still have the same time. Okay, but the speed at 60 degree north was 240 knots. Now the speed at the equator, what should it be? That we have to find out. Now we know that here the distance was less. Here the distance is more than that, and you have to cover the say this much more distance in the same amount of time. Okay, so that means when you're flying at equator, you will not be it will not be sufficient to fly at the same speed of 240 knots. When you arrive at the equator and you have got the same time available in your hands, you will have to increase your speed to more than 240 knots so that you complete or you fulfill your goal of completing 360-degree turn at the equator in the same amount of time. Otherwise, if you continue at 240 knots at the equator, in 10 hours you will not be able to complete 360-degree direction. That you will successfully do at 60 degree. But at equator that won't be the case. At equator the distance is more. So to cover more distance in the same amount of time, you will have to increase another element, which is speed. Okay, so definitely at equator the speed will be more than 240 knots. Okay, because equator distance is more than 60-degree north. So this is basic speed equals to distance upon time formula logic, nothing else. So going by that option, by this concept, I can easily eliminate option number Bravo and Delta, because I know for sure my speed has to be more than 240 knots. So 120 cannot be the option, 240 also cannot be the option. So two probable options are 600 and 480. So let's find that out. So let's start writing. Distance that you cover at 60-degree north is equal to, that will be equal to your rhumb line distance. Do you agree? All latitudes run east and west direction, and all latitudes are rhumb lines because they have a constant direction of either easterly or westerly. So rhumb line formula is, so when you make a 360-degree turn along 60-degree north latitude, okay, in easterly direction, you are in other words traveling a rhumb line track. So we can calculate the rhumb line distance. D long into minutes into cos lat. So D long is how much? So you are making a difference in longitude. So the difference in longitude here will be a 360-degree turn. So 360-degree into, convert that into corresponding minutes, which is 60 minutes, into cos of latitude cos 60. So 360 into 60, cos 60 is half. So that will be equal to 10,800 nautical miles. 10,800 nautical miles. So when you travel 360-degree at 60 north latitude, you are covering a distance of total 10,800 nautical miles. Now let's calculate the time required. The time that you take will be equal to distance divided by speed. So distance is 10,800. Your speed is given 240 knots. So 10,800 divided by 240 is 45 hours. 45 hours. That means you have covered 45 to 10,800 miles in 45 hours at 60-degree north latitude. Now you got to cover in same amount of time, that is 45 hours, the whole distance at the equator. So now let's come down to equator. So again, equator will be a rhumb line distance d long into cos of lat. So rhumb line distance at equator will be 360 degree into 60. Latitude at equator is 0. Cos 0 is 1. So 360 into 60 is 21,600 nautical miles. That is at equator. So now we have distance with us. We have, so speed is equal to distance upon time. So distance is 21,600 Time available at to us is 45 hours. So divide this, 21,600 divided by 45 is 480 knots. So at equator, our conclusion is that at equator you fly at 480 knots ground speed to make a 360-degree rotation in 45 hours. In 45 hours. Okay. So the correct option from this two remaining will be option number Charlie, 480 knots. So first we understood this concept, basic speed distance time concept. Here the distance was less, here the distance is more, and the time available to the pilot to cover 360-degree distance, angular distance at both latitude is the same. So the speed at one latitude will be different than the speed at another latitude. So speed at 60-degree north, 240, speed at equator more than that, because at equator, because of the shape of the earth, you have to cover much more distance. Okay, so approximately twice. So 240 knots was required at 60-degree north. At equator you required 480. So which is twice of that. Okay, so we'll have to fly at twice the speed. Question 15. Your position is 58 degree 33 minutes north, 174 degree west, initial position. So A is here 58, 33, 174 west. You fly 6 nautical mile eastward. So from A you're going towards the east for a distance of 6 miles. What will be your new position? Okay. Now when you fly easterly or westerly, you are actually flying a Rumline track. So let's employ Rumline distance formula. Let's take a new slide. So very simple formula based sum. Rumline distance is d long in minutes into cos lat. So 6 miles is equal to d long into cos of 58 degree 33 minutes. So d long is equal to 6 divided by cos of 58 degree 33 minutes. Divide it. So that is 11 minutes. Okay. Or if you divide it by 60, you get answer in 0 degree 11 minutes. So same thing. Okay. So this is the difference of longitude. Now let's draw the earth. So whenever we are talking about longitude, it is safe to draw the earth so that there is no confusion later. 0, 90 east, 90 west, 180 east and west. So longitude, initial longitude was 174 west. Now we are going to fly easterly direction, right? We are flying easterly direction as they have stated here. All easterly directions are anti-clockwise. All easterly directions are anti-clockwise. So that means when you go left hand direction and you are in the western hemisphere. So as you start from 174 west and start going anti-clockwise on left hand, the value of longitude will go on decreasing, 174, 173, 172, so on and so forth. So it will decrease by a value of d long, right? So now our new longitude will be equal to initial longitude minus d long. Initial longitude is 174 degree west. Difference in longitude is 0 degree 11 minutes west. Just so new longitude will be 174 degree minus 0 degree 11 minutes, which is 173 degree 173 degree 49 minutes west, since we are in the same hemisphere. So our new longitude will be 173 degree 49 minutes western longitude. So same latitude and 173 degree 49 minutes. So 48.5 is 48, 173 degree 48 minutes and 5 seconds. So this will be the closest option. 48 minutes, 49 minutes, close, very close. So simple formula, draw this. Understand you're going easterly direction. So when you understand that, you can draw a diagram like this. So you come to know whether your final longitude is to the right of it or left of it. So easterly means anti-clockwise, so it will be left of it, decrease in value. Use the formula correctly, substitute the values, and then find the answer. So with this, we have come to the end of this lecture, and we have solved all questions from departure Oxford General Navigation. I hope with this, you are able to answer all the 15 questions from this chapter confidently. It will be very useful if you keep practicing again and again, and also start practicing on your own. And when if you are very comfortable with all these 15 questions, you will definitely be able to solve any other question asked from R.K. Bali or Keith Williams or in DGC exam. So do hit the like button, subscribe to this channel, and do share this video with all your friends. All the best, keep learning.